This video we are going to talk about semiconductors. So semiconductors, in terms of their conducting properties, they're somewhere in between conductors and insulators. They have small band gap. So this is an example of a semiconductor, and we will talk about a lot of them in details. So for the classification, we have an intrinsic semiconductor, and we also have an extrinsic semiconductor. For intrinsic semiconductor, we have pure. They comes with germanium and silicon. For an extrinsic semiconductor, this is when we add impurity to our intrinsic semiconductor, and thus we can create the N-type and P-type semiconductors. For N-type, our impurities here are pentavalent, meaning they have 5 electrons in their valence shell, and they could be phosphorus, arsenic, antimony, and others. For a P-type, our impurities are trivalent. They have 3 electrons in their valence shell, so they could be gallium, boron, indium, and aluminum. Let's talk about the energy gap of semiconductors. This is the energy required for the electrons to jump from the valence band to the conduction band. So we can see here that it has a small gap here. Let's go to our examples. We have silicon. This is referred to be the king of the semiconductor. This is an intrinsic type, and its energy gap is 1.12 electron volts. So this is its raw form, and we can fabricate them into an electronic chip. Next, we have silicon boron, and this is an extrinsic and a p-type semiconductor. Its energy gap is 0.04 electron volts. This happens when silicon and boron try to create a stable covalent bond between them. They actually have a vacancy here, and this facilitates the flow of electrons in the material. We also have silicon carbide, and this is the wide bandgap semiconductor. This is intrinsic. It's because this is composed of equally proportioned amount of silicon and carbon, and it has energy gap 3.3 electron volts, and we can actually use this in high temperature and high frequency operation. So this is its raw form, and we can create transistors out of it. Last, we have the iron pyrite. This is an intrinsic semiconductor and also an N-type. Its energy gap is 0.95 electron volts. So in summary, we have our semiconductor materials here, their type, and their energy gap. So we can see here that doping really gives us a different energy gap. It decreases the energy gap, and we can actually create a whole lot of characteristics by doping our semiconductor materials. So we owe to them a lot of our technological advances, most especially in electronics and information technology. So that is all, guys. Thank you so much for listening, and may God bless us all.